food. I guess I better think about food. Whereas right now, I'm thinking about food. I mean, like that was an item on my calendar, eat at Cowell. You know, so it's like underlined. And last night I ate at Crown, and the lunch before that I ate at College 910. So I'm on my world tour. Oh, we're here, guys. We're here. You're mine now. Okay, I don't know if you guys know this. This is one of the world's most famous XKCD comics. XKCD, I love them. Someone is wrong on the internet. That's one of the famous ones. If you like geek humor at all, you might want to check it out. I asked them to send me the name of anyone from my class who goes to these things so I could give you extra credit. So if you go, tell them you're in CE16, okay? I'm especially believing that the exponents and logarithms and the polynomials will be useful to you, okay? You don't have to, just if you do, I want to be able to give you some credit. All of these sheets for the rest of the class will say when the final is. I don't care if you are, going to go have sexual congress with, who are the hottest people? Scarlett Johansson and who's the name of that handsome Lannister dude? The brother, Jamie Lannister. I don't care if you're going to go, you can get them. I will not let you out of this final. Okay? I don't care if you're leaving for spring break. I just don't care. You can't pass this class without taking the final. In fact, you can't pass this class without passing the final. Okay? We love our TAs. There are some errors in the self-grade reporting. I had at least one person very upset because they thought they'd screwed up submitting the homework, but we actually had all of their homework recorded. So if there's something on the sheet that you think is wrong, the person to talk to, if it's a homework problem, talk to Victor. If it's you're not on the sheet, talk to Avi. That means I sent your email to the wrong person. Anyway, their email addresses are actually on the website, even though they're not here. So Victor for homework grades, and Avi for just plain stuff. Sections are where you get your quizzes back and where you get help. Were there really 10 people at an MSI where no one showed up today? Yeah? How late did you stay?
45 minutes.
Did he drop? Were you supposed to handle this section on Friday?
No.
He emailed you?
Felt sick.
Well, that happens. If he had dropped, the obligation, I wanted to know. I'm sorry you guys didn't get help. There's going to be 2 proofs on your quiz today. One of them is all propositional logic, and one of them has to do with numbers. You need to give 2 column. I'm giving you all the rules for all the reasons for why I get to do this for both of them. So it's as formal as you can make it be. And then I feel really bad for poor Marcelo. This is the hardest to grade I've given. Yes?
For mathematical proofs, instead of saying arithmetically equivalent, can we give like the mathematical properties?
Oh, yeah. Yeah, but I didn't put those properties on. Okay, so the question was, you guys are more talky today. I feel like I'm going to rip out my voice if you don't shut up just a little bit. Or to put it more nicely, shut the fuck up. He said, if we're doing a proof where we're looking at numbers, instead of saying arithmetically equivalent, could we put down the rule that we used, like the commutative rule, the distributive law, whatever.
Or like subtract x from both sides.
Yeah, you can put down the reason. The only reason I'm not asking you to give the reason is because that's not printed on your quiz. What's printed on your quiz is the rules of inference. And there's really only one place on your quiz for a place for me to put all the rules, right? But feel free to give reasoning. And in general, I know you've been trained all your life to try to keep your instructor from knowing how little you understand about the subject you're trying to get a good grade in. But I guarantee you in this class, the more clue you can give us as to what you're doing, the higher the probability you will actually get partial credit, even if you get something wrong. So if you say subtracting x from both sides, and in fact you add x to one side and subtract it from the other, the fact that we knew that's what you were trying to do might get you half the points instead of 0 the points. Okay? Also, if you're especially confused by proofs that involve right arrows, implication arrows, do the number one first, or vice versa. They're both worth 5 points. It's a 10-point quiz, and each proof is worth, there's 2 proofs. 2 questions on proofs. Marcelo is going to kick my ass, because it's going to be hard to grade. Marcelo, are you here yet? Are you here? I see a hand. Is that Marcelo back there? There's no way I can see. No, you want to ask a question? You just want to pretend to be Marcelo? Wow, I'm going to tell him he's a celebrity. He's one of the guys with he's the guy with the dot beard, the beard I had to add. Okay, let's make sure we have, remember how I always review slides before we move on to new material? Let's do the reviewing stuff.
Remember how we don't do new material before quiz?
We're going to do a little new material, I hope, unless you guys ask a lot of questions. It turns out I'm feeling just a little behind, which is why you have repeat homework for next week. If you did all your homework this week, you get a break for next week. I repeated a section of homework for next week. So if you did the chapter 2 homework for this week, then you already did it. Don't worry about it. There's still other homework besides that. Okay, so let's make sure you guys understand. What's going on? I wish I knew how to do this, you know. Somebody who knows how to do that, I'll bring you up and do it. Yeah, that, like that. Only I want to do it into the mic. Okay, so a formal proof is a sequence of propositions. The last one better be the conclusion. If you're doing a proof by contradiction, the last one is false. Now, each one of those propositions has to fit a very narrow set of rules. You only have 4 rules. It's one of the hypotheses. It can be inferred from previous propositions. It's a known tautology, or it's logically equivalent. If you're doing a proof about numbers, you could say arithmetically. So, for instance, suppose you have A plus B plus C. You can change that to equals D. You could change that to A plus C plus B equals D, right? Because of the commutative property. But you don't even have to say commutative property. You can just say arithmetically equivalent or mathematically equivalent. I don't care. You could say you're just using those nice identities that you've been using since you were in junior high. That's just fine. You have a set of hypotheses and a conclusion, and then your proof is a sequence of propositions. Your rules of inference always look like some number of propositions that appear on separate lines in your proof. And if all of those things appear on lines on your proof, you can conclude the thing after the 3 dots. And you are going to get this fine chart right on your quiz. It's going to be printed on the front of your quiz. So you do not have to memorize this at all. So for example, if one line of your proof says P, and another line of your proof says P implies Q, P and V is for operating systems, then you get to conclude Q. Here's a really important thing that is so obvious to someone who's been doing math for decades that she can forget to make this clear. I said here, I'm trying to prevent my leg from dying. But anyway, you see up there where it says P and P implies V? If instead of P and P implies V, you have A and A implies, let's have what's a good letter? Z. That works too. It doesn't matter what the variable's name is. The variable's a placeholder, right? That makes sense? Okay. Sometimes I have people, yes, that's good. But, yeah, just that one, good. Sometimes I have people who don't understand about variable substitution. But let me tell you something else that may be a little bit harder. Even if you have something like A or B implies C, and you know A or B, you can conclude C. Once again, because of variable substitution. If you want to do this a long way, you can say, hey, set new variable Bob equal to A or B. Bob implies C, and we know Bob, therefore C. It's the same thing. It's all variable substitution. It would be modus ponens. Just straight modus ponens. I just want to make sure you guys are comfortable using modus ponens. You have thingamabob implies B, C. And then you have thingamabob. It doesn't matter if thingamabob is one character or a proposition, a one character proposition or a compound proposition. As long as it's identical. Make sense? Probably to be safe, you should go out of your way to put like parentheses around this, you know? Just so everybody knows that we're not talking about A or the quantity B implies C. Okay, no memorizing. It's all right there on your quiz. Okay, so we did examples. I'm going to go really fast this time. But you have some collection of hypotheses. Nobody makes you use all the hypotheses. That's not needed. You use which ones you need. If you know not P or Q, then you know not P by simplification. If you know R implies P because of hypothesis, then you know not R by modus tollens. If you know not R implies S by H3, then you know S by modus ponens. If you know S implies T by hypothesis 4, then you know T by modus ponens. And honestly, the kinds of stuff I give you on the quiz, you could practically blunder into the right answer. Yes? No. I recommend that you have blank, this is important, blank scratch paper for today. Like if you have like can I hold your book for just a second? I suggest that this fine gentleman in the front, oh my God, you might not have a blank page. Okay, he should take a blank page, rip it out of his book so that he can have a blank page, because if he first figures it out with 10, maybe he would like 10 steps, he would like to then write it neatly in the space provided. What? I didn't bring a stapler, guys. I'm suggesting scratch paper so that you can work it out and then write it neatly onto your page. I'm not asking you to turn in your scratch paper. Okay? So, a vacuous proof is one where where the hypotheses are false. You never have to go there.
What is it with that comment? You and that comment?
My mom's ass is in fact not fat. It doesn't matter, but it doesn't matter. If that B, my mother is not a B. Although, in the 70s, my strange father decided that he wanted to create a brand of tennis shoe known as the Larrabee. Well, let's just say that my family had financial issues for a while after that. Also, it turns out that manufacturing shit takes a lot of expertise. And like, I had an entire garage filled with left shoes. Anyway, trivial proof is one where you don't need the hypotheses at all. There's no need. You have no trouble if anyone in the class has ever won the lottery, 1 equals 1. Well, the 1 equals 1 no matter what, whether or not anybody won the lottery. So here's an incredibly trivial little formal proof using implications. If you know P, and you know P implies Q, on your quiz, this is what you should do. The first thing you do is label hypothesis 1 and hypothesis 2, and C, your conclusion. And you go in very tiny steps. In fact, it's never wrong to write down all the hypotheses. Like there's 2 hypotheses there. Your first 2 propositions in your formal proof should be the hypotheses. You don't always have to use all your hypotheses, but no one's going to take off points because you wrote down your hypothesis and didn't use it. Okay? So if you know P and you know P implies Q, then you know Q because of modus ponens. And if you know Q and anything else you want to say. Well, actually not anything else you want to say. You know P or anything else you want to say. And you know P and Q because you previously knew P and you previously knew Q. Everybody see? That's the conjunction rule. Sorry, I was in the middle of another proof. If you want to show that if you know that P and Q implies R and that Q implies P, and you know Q, let's prove R. All the ones that I could put on the quiz all look like this. It's just a collection of stuff. And then I want you to come up with some reason to get R for your last proposition in your proof. If you know P and Q implies R, and you know Q implies P, and you know Q, then you can use modus ponens on 2 and 3 and get P. And then you can use conjunction to get P and Q. And now that you know P and Q, and you know P and Q implies R, you now know R. This is how hard it will be. That is to say, you could almost do it by accident. Let me tell you, the workhorses are modus ponens and modus tollens, but you can completely avoid modus tollens if you just do logically equivalent with contrapositive. There are a lot of proofs that become really easy if you use resolution instead of modus ponens and modus tollens. But most students new to this kind of proof are less comfortable with resolution. I'm suggesting you don't go the resolution route unless you like this stuff and have been thinking about it rather than sex at night. Yes? Resolution? Maybe if you're in Kyle's section, you want to use resolution because stuff, I'll be straight with you guys. Resolution is incredibly powerful and stuff just falls out. But a lot of people, it takes them a while before they become comfortable with resolution. It'll be right there on the sheet with all the other ones. So if you want to look about whether or not it helps you, feel free. Where were we? Proof by contradiction. So when proof by contradiction, you basically get a new hypothesis that is the negation of your conclusion. So before we had H1 and we had a conclusion. And once we start doing proof by contradiction, we have H1 and H2, and our conclusion becomes false. The last line of the proof you want is false. So if you know P implies Q and S implies Q and not S implies P, prove Q. Instead, if you can either do that as a direct proof, or it turns out to be really easy if you do it as a proof by contradiction. So now we have hypothesis 1, hypothesis 2, hypothesis 3, and hypothesis 4, and you're done when you get to false. So you know not Q from hypothesis 4, you know P implies Q from hypothesis 1, so you know not P because of modus tollens. And you know not S implies P from hypothesis 3. That means you know not S by modus tollens, and you can take the double negation, call it logically equivalent. So you know S. You know S implies Q because hypothesis 2. That means you know Q. Now you can use conjunction to take Q and not Q and get false. Make sense? Okay. Proof by contraposition. That's where you realize that it's easier to prove the contrapositive of what you're trying to prove. For example, you look up here and you say, oh my God, I'm supposed to assume a square and prove something about the square root. Oh Lord, and it's about integers. We don't like proving things about square roots with integers, right? Because the square root of 3, square root of 2, square root of 7, very, very ugly quantities. Definitely not integers. Okay, so instead of proving that if n squared is even, that means n is even, we're going to go out of our way to prove that if n is not even, then n squared is not even. And not even is another way of saying odd. So if n is odd, n squared is odd. This proof already looks better, because multiplying n by itself, way better than taking this, multiplying both sides of an equation by themselves, much better than taking square roots of both sides of the equation. So to do this, you have to do what you do a lot in math, which is write down the math for like a common concept. Like I bet my kid knew what the difference between even and odd when he was at least by kindergarten. But he didn't know that odd means there exists an integer m such that n is equal to 2m plus 1. Formalizing common arithmetic concepts is something that takes a while to become comfortable with if you haven't been doing it. So if n is equal to 2m plus 1, then n squared is equal to the quantity 2m plus 1 squared. Now, we'll do a little bit of polynomial manipulation, and 2m plus 1, the quantity squared, is equal to 4m squared plus 4m plus 1. That's just what you get if you multiply 2m plus 1 times 2m plus 1. And this part is divisible by 2, and then you add 1. So it's itself an odd number. So saying, when you say 2m squared plus 2m, 2 times 2m squared plus 2m, we can restate, we can take this part inside the parentheses and give it a name. So now we can say that n squared is equal to 2k plus 1, so that means n squared is odd. So we just proved that if n squared is even, n is even, and the way we did that is we proved that if n is odd, n squared is odd. Make sense? Are we happy? Yes, we are. Yay! Look, a voice from the back of the room. Okay. Prove the square root of 2 is irrational. I don't think I spent enough time on this one. I'll give you a break, guys. This one is not on the quiz today. I find it exceedingly likely that something involving square root of 2 is going to be on the final then, since I didn't put it on your quiz. Okay, come with me. It's not that bad. Honest, come with me. What's freaking you out? The square root sign and the GCD? Okay, GCD means if you have two numbers, x and y, the GCD of those two numbers is their least common denominator. You did this in high school, I guarantee. You got into a UC. You can think of it as a least common divisor if you want, but usually we do least common multiple for the LC. So GCD, if you had education in a British Crown colony, you might have called this a highest common factor, HCF, which sounds like a fluorocarbon that's going to get rid of the greenhouse gases or something to me. You and then you, yes? If they're both even, then they're not in least terms. Okay, I haven't gone through the proof yet. You have to wait until I go through the proof to ask that, okay? Wait. Europe. Okay, look up there. Instead of going through it line by line, let me tell you that the whole thing bears on assuming if you have a rational number, you need to be able to represent it as a fraction in least terms. That's the definition of a rational number, is something that can be represented as a over b, where they are in least terms. So 1/4 works, 2/8 does not work. 10 579 billionths doesn't work because that's not in least terms. If there's any factor of both the numerator and the denominator, if there's any factor in common, then it's not in least terms. So this whole proof goes like this. It says, hey, let's assume that the square root of 2 is rational. Well, if it's rational, then by definition, you can represent it as the ratio of two numbers, a and b, in least terms. Let's now look at what has to be true about a and b, given that square root of 2 equals a and b. Square both sides. Now you get a squared over b squared. You do a little bit of math because a squared over b squared equals 2, and you figure out that a has to be a multiple of 2. If you look behind me. Okay, then you do a little bit more substitution and you figure out that b has to be a multiple of 2. If they're both multiples of 2, then they weren't in least terms. That's the whole proof. And I know that seems weird. It's kind of like I proved that there was a famous gangster who like murdered hundreds of people, but the only way they were able to catch him was tax fraud. Al Capone. It's kind of like that, right? It seems like it's this big earth-shattering thing, and you're catching him because he fibbed about whether or not he was in least terms. But this is an important thing. If the square root of 2 is rational, this is a proof by contradiction. You're trying to prove that the square root of 2 is irrational. Well, let's assume it is rational. Follow the direct implications of it being rational, which is to say that the square root of 2 is represented as the ratio of two integers, which we don't know what they are. They could be, something with 17 decimal points divided by something with 16 decimal points, right? So we're not saying what we know what those numbers are. We're saying that if the square root of 2 is rational, it has to be represented by the ratio of two numbers that have no factors in common. The way you say no factors in common is you say GCD of those two numbers equals 1. That's what GCD equal 1 means. So this whole proof revolves around if the square root of 2 is rational, it's representable as the ratio of two numbers in least terms. Well, if it is, then we can square both sides and do a little tiny bit of algebra and show that one of them is divisible by 2. And then we can do a little more algebra and show that the other one's divisible by 2. If something divisible by 2 is divided by another thing divisible by 2, that's not in least terms, right? And the way you say is in least terms is you use this mathy terminology. GCD of the numerator and the denominator is equal to 1. Okay? Now, where is my Chinese friend? Well, you are also my Chinese friend, but that guy back there who asked the question. Did I answer your question, sir? Bu hao, bu hao. Say that again. Sometimes you do something wrong. Ain't it the truth, man? I woke up at 2 a.m. obsessing over something embarrassing I did in a meeting yesterday. So anyway, sometimes we do something wrong. You know what? If you're careful, if you go in small steps, you only do things that you know how to do and you know where you're headed, you won't do something wrong. What? It won't make any sense to you. I could tell it in French and it would make just as much sense to you. J'ai dit quelque chose qui ne c'est pas vrai et les autres dans l'ensemble a dit que j'étais tort. Sorry, was I too close to you, Joyce? Anyway, I did that one far away, so it's okay. Okay. So the GCD, this line here says that says that A and B are not in least terms. That's what that thing circled there says. A and B are not in least terms if their GCD is anything other than 1. 1 divides all numbers, right? Okay. So that's all there is, and it's not on the quiz today. Also not on the quiz today are any explicit quantifiers. So the fact that if you know for all x p of x, you know p for any particular value. Also, universal generalization. If someone says, we know p of c for arbitrary c, that's another way of saying for all x p of x. That is also not on the quiz. Also not on the quiz is that if you say there exists an x p of x, you can give the at least one x you know it's true for a particular name. You can call it George or, you know, Q or whatever you like. If p of c is true for some element c, that's the same way as saying there exists an x p of x. And if you know for all x p of x implies q of x, and you know p of a, you can imply q of a. This is what's known as universal modus ponens. Once again, this is not on the quiz today. Proof by cases. I want you to put a pause here. As a geek programmer, I want to tell you that I'm going to push that topic on the stack and we'll pop it off later, okay? Because I'm going to prove the triangle inequality to you soon. Kyle has been through the triangle inequality many times. Let's talk about functions. Yes? Just for a second, pretend. I want you guys to empathize. Pretend you're me and you're standing at the front of the quiz, at the class, talking about all the wonderful mathematics in CE16, which I honestly believe is fucking cool. Okay? How much do you like, will this be on the quiz as a question? Just guessing. I'm not trying to give you a hard time. You in particular. I'm trying to give you a hard time, but not you in particular. And I don't even remember who you were. Probably you had purple hair. I don't remember. No, there are no functions on the quiz. Are you trying to tell me you need an extra 7 minutes on the quiz? Can I talk about functions for 7 minutes, please? Okay. So, we are going to map the elements of one set onto another set. A hell of a lot of discussing functions in discrete math is just terminology. If you map the elements of set A onto set B, then it's very common to draw it like this. Okay? Now, we say that F maps A onto B. Another way to write that is the function f such that elements of A are mapped onto B. In this case, that's not an implication error. We reuse symbology in discrete math a lot. Another thing to say, I'm going to get this right, watch this, is that f is a subset of the Cartesian product of A cross B, which is to say it's a set of ordered pairs. So if, for example, if f of A is equal to B, another way to say that is the ordered pair AB is an element of the function. A function in discrete mathematics is a set. That's very important. And most of the time when we're talking about very small sets, we draw pictures like this, where we have all the elements of one set on one side and all of the elements of the set we're mapping things onto on the other. It's possible for them to both be the same set. So you can map letters of the alphabet onto letters of the alphabet. How many of you know what a Caesar cipher is? Okay, so a Caesar cipher is a one-to-one mapping of the letters of the alphabet onto the letters of the alphabet, shifted by one. So like if you map A onto B and B onto C, then it's like everybody's going down one. Yeah. Yeah, and in the much more trivial course, Intro to Python, they had to do Vignere ciphers where the function of how far you rot is part of the function of the thing you had to write. Say that again? The last few months of your life have been trivial. Oh. It's a simpler introduction to programming than than, for example, CE12 is. CE12 is supposed to be a harder, more complex course than CS5J or CS5P. Yes. CS5P? No. I'm sorry. Look, I like teaching you guys too, but it turns out that there are a lot of people who can teach CE12. Ethan Miller and Daryl Long are moving to computer engineering. They're very good at teaching CE12. There are a lot of people who can teach CE12. There will be more options than just Max next year for CE12 for sure. And I love teaching CE16. I love this material. Wait. Okay. If f of A is equal to B, you say that B is the image of A, and A is the preimage of B. I've not yet even gotten to where we were on Wednesday, guys. I have 4 more minutes. Okay. Think of it this way. You have the 2 sets, and you have them set up like this. And you're going to put A here, and you're going to shine a light on it, and where it lands, that's the image. And that's what it's mapping onto. That's my metaphor. He wanted a metaphor for why you call it an image, and I said what I said. Okay. 1-to-1 is where every image is only used once. If you have f of A and you have f of B, the only way they can map to the same thing is if A equals B, is the way you say that in Mathese. You say, you never have 2 incoming arrows go to the same thing. The reason that big red not sign is there is because you have 2 arrows going to the same thing. That's illegal for 1-to-1. Onto says that you use up all of your target dots. And if your function is both 1-to-1 and onto, it's a 1-to-1 correspondence. And we are going to use the concept of a 1-to-1 correspondence rather heavily in this class, especially when we talk about cardinality. Which of the following, this is the last slide I'll use. Which of the following are 1-to-1 onto or 1-to-1 correspondence? A function from the integers to the real numbers given by f of x equals x squared. First of all, let's just get real. There is no function under the real numbers that is onto, right? You can't map integers onto real numbers and use up all possible real numbers. The real numbers are not countably infinite. Okay? How about, do you ever have, is it 1-to-1? No, because f of 3 equals f of negative 3. You have 2 arrows going to the same target. It's not onto, it's not a 1-to-1 correspondence. How about the functions from the reals to the reals given by f of x equals x cubed? That is a 1-to-1 correspondence. Yeah, there'd be a mess. We don't do that. Don't picture the graphs. The graph from the integers to the real numbers given by f of x equals absolute value of x. No, because absolute value of 3 is equal to the absolute value of negative 3. How about the function from the positive integers to the positive integers? It's 1-to-1, but it is not onto. Right? Because nobody is mapping onto 7. Because you can't square an integer and get 7, right? Or 8 even. Okay. We are ready to pass out the quizzes. Too late for a question right now. Okay, I'll get you quizzes. Yes, I know. You have to make sure you bring your jacket on Fridays.